This is the review solutions to the Math 111 final exam. And the final exam will consist of both a calculator and a non-calculator portion, though in this case the majority of the exam will be on the non-calculator portion. The calculator portion will only include questions on solving triangles, working with vectors, and solving trig application problems such as bearing, angle of elevation, etc. On the non-calculator portion, you will be provided a blank unit circle to complete, so you're going to want to make sure you know how to fill that in quickly and accurately in order to take advantage in working problems using it. I'm not going to go through example on how to do that. You can review prior videos in order to see how that's done. Number 1, evaluate the following. Sine of 225 degrees for part A. Well, we just want to get out our unit circle and start answering. So, as I said, once you have your unit circle filled in, these types of questions become relatively straightforward. You just have to look up the solutions. So 225 degrees, sine is the y value. So this is going to be negative square root of 2 over 2. Cosine of 120 degrees. So 120 degrees is here. Cosine is the x value, so negative 1/2. And this is pretty much how these are going to go. For tangent, you just have to remember that tangent is the y-coordinate over the x-coordinate. So for 270 degrees, which is here, this would be negative 1 divided by 0, and so this becomes undefined at that particular point. Cotangent of 45 degrees. Just find out where cotangent is 40. Well, find the 45 degree angle. Cotangent is going to be x over y. So the x and the y are both square root of 2 over 2. So this would equal 1 when you divide those two. For cosecant of 330 degrees, so here's 330. Cosecant is going to be, it's related to sine, except instead of it just being the y-coordinate, it's 1 over the y-coordinate. So 1 over negative 1/2 is going to be negative 2. Secant of 210 degrees, recall that it's just related to cosine, and so 1 over the cosine of 210, so 2 tens right here. The cosine is negative root 3 over 2, so this is going to be negative 2 over root 3, but when you rationalize the denominator, it becomes negative 2 root 3 over 3. Sine of 450 degrees. Well, for sine 450, what you have to keep in mind is in order to do this, you need to get a coterminal angle. So 450 minus 360 is 90 degrees. So this would be the same as sine of 90 degrees. And sine is the y-coordinate, so that's going to be 1. Cosine of negative 150, same concept. You need a coterminal angle, but in this case, we should add 360. So when we take 150 plus 360, which is going to be 210. So we find 210 degrees. Alright, so that's here. We've already gotten that once before. And I want the cosine, which is going to be negative root 3 over 2. Okay. Going on to the next group, we just have the same sort of setup, except everything is in terms of radians instead. And as long as you have listed your angle measures on your unit circle in degrees and in radians, this is no different. So sine of 2 pi over 3, there's 2 pi over 3. The sine is the y-coordinate, which is root 3 over 2. Cosine of 5 pi over 4, here's 5 pi over 4. The cosine is negative root 2 over 2. Tangent 11 pi over 6. So tangent is going to be y over x, which in this case would be negative 1/2 over root 3 over 2. So if you invert and divide, the 2's will cancel, so it's negative 1 over root 3, so negative root 3 over 3. Cosecant of negative pi over 3. Well, negative pi over 3, you would technically need a coterminal angle. So you could do like negative pi over 3 plus 2 pi. But instead of writing 2 pi, I'm going to write 12 pi over 6. Oh, I don't know why I would write over 6, because I need a common denominator of 3. So over 3, so this would be 6 pi over 3. That would be the same as 2 pi, which becomes 5 pi over 3. So right there. Cosecant is related to the sine, which is going to be the y-coordinate. So it's 1 over the root 3 over 2. So negative 2 over root 3. And when we rationalize the denominator, negative 2 root 3 over 3. All right, the remaining ones. Secant of pi over 3. There's pi over 3. And secant is related to the cosine, so it's going to be 1 over 1/2, which is 2. 7 pi over 4 is right here. Cotangent is x over y. Since they're both the same, it becomes 1, but there's a negative on the y-coordinate, so it should be negative 1. So as long as you have your unit circle handy, questions like those can go relatively quickly. Just take the time to draw out an accurate unit circle, and that will make those very easy. Number 2, graph the following. Identify the amplitude, period, phase shift, domain, and range. Okay, so amplitude, phase shift, I missed period, so period, domain, and range. Alright, so the amplitude comes from this number multiplying, the 3. So that is our amplitude. Just use it as is. The phase shift comes from this number. And that tells me that I'm moving pi over 4 units, but it moves in the opposite direction of the sign, so this is going to be to the left. Alright, the period comes from this number, except it's 2 pi over that number. So in this case, it becomes 4 pi. Then the domain and range, I'm going to hold off on until I have the graph drawn. Okay, so let's do some marks here. Alright, so the amplitude is 3. So normally, my graph bounces between positive 1 and negative 1, but now it's going to go all the way up here to 3 and down here to negative 3. Okay, so it's bouncing between those values. The phase shift is pi over 4 to the left. Okay, now cosine generally starts, up here at positive 1, and then it goes down and then back up, by 2 pi. So what that means is if all I had was an amplitude change, then I would start right there. but it's going to, because I have a phase shift of pi over 4 to the left, I'm going to move that particular point back to the left. So I'm going to draw that in blue because that's going to be part of my curve. Now the period, that's the entire time it's going to take to complete the cycle. Normally it's 2 pi. If all I had was this amplitude change, that would finish by 4 pi, so I would be here. And then 2 pi, I would halfway between, I would be at my minimum. And then at pi and 3 pi, I would be at 0. But everything's getting shifted back pi over 4 to the left. So I'm just going to move all these green points back pi over 4. And that right there is enough for me to draw my cycle. So there's my cosine wave right there. Now, in terms of domain and range, the domain is going to be, this function is going to be defined everywhere. So the domain is going to be negative infinity to positive infinity. That's just a property of sine and cosine. It's always defined. The range, however, the range is going to be between negative 3 and positive 3. So it's restricted based off of that amplitude. Next one, y equals cosecant of 2x. Now with cosecant, the graph is basically the same as sine. We just have to remember to invert everything in the very end. So it actually gives us practice with drawing a graph of sine as well. But we need to identify the basic pieces, like amplitude, period, and phase shift. So amplitude in this case is just 1 because there's no multiplier on the function. The period change, normally it is 2 pi, but it's getting divided by 2 because the multiplier on my x. So my period now is just pi. There's no phase shift because there's no number added or subtracted from the x. And there's no vertical shift either. So let's draw the sine wave that's according to this, and then we'll get cosecant from that. Alright, so the sine wave normally is going to start at 0. It will go up to its maximum, then back down, and back over here to 0 by 2 pi. Alright, so there's no change in phase shift, so 0 on my sine is still going to be at 0 here. Amplitude is still 1, so the only thing that's changing is the period is now pi, which means I'm going to finish my cycle by pi. So at pi over 4, I would be at a maximum, so that pi over 2 I'm back to 0, and then 3 pi over 4 I would be at a minimum. So the sine wave would bounce between just like this. Okay? But we're not graphing the sine wave. Actually, let me make that green. Okay, I corrected a couple of things. First, I made it green because that's not part of the actual graph. I'm going to make the actual graph blue. Secondly, I made my amplitude 2 in the previous part, so I changed to the amplitude being 1. Okay, so those being corrected, here's the actual graph for cosecant. Now, wherever sine is 0, cosecant is going to be undefined, and thus we'll have an asymptote there. Because asymptotes occur when you have 0 in the denominator, so when you invert sine, that occurs. And in between, cosecant has a minimum or a maximum wherever sine has a minimum or a maximum. And you just kind of make this type of graph to fill in. And there you go. Number 3, write an equation for the graph below. Okay, so we just need to examine this graph. It could be sine or it could be cosine, but let's see what we can do to determine which it is. First thing first, I want to determine where the middle axis is, okay? And I think it's going to be right along here. And the reason I know that's the middle of the horizontal axis is because there's as much displacement above that axis as there is below the axis. In this case, it looks like, so each unit is worth every two, okay, so the scale is a half. So this would be -1, -2, -3. So this would be 2 below 1, and this would be 2 above. Okay, so yeah, that's the middle of my horizontal axis. But that actually defines the amplitude as well. So let's go ahead and jot that down. So the amplitude of this graph is 2. Okay, the period. So the period is going to be the distance between two maximums or two minimums. So in this case, the period, okay, let's find out where that point is. So this would be like -π/4. So this would be -3π/4 and -5π/4. Then this point this way, if this is π/4, this would be 3π/4. So basically, if I took 3π/4 minus -5π/4, that gives me 8π/4, which is 2π. So that means my period is still 2π. So there's no change to the period. Okay? Now, other things about this graph. I need to determine things like phase shift, and also I need to decide if this is going to be the graph of sine or the graph of cosine. So if I choose the graph of sine, then what I have to recall is for the graph of sine, it's normally going, starting at 0, going up, then back down, and then by 2π, coming back at 2π. If I call this sine, and I call this my starting point, the problem is it's going up first. It's starting at a minimum and then going up. So that doesn't really fit unless I make a pretty large phase shift. So let's go with this being cosine, because it doesn't really matter. You can use either one. I'm going to go with cosine. I think that's going to work best, because cosine starts at its maximum, comes down, and back up to its maximum by 2π. But you'll notice here, it's basically just going to be flipped. So it starts at its minimum, goes all the way up to its maximum, and then back down. So that's what's happening here. So this would be negative cosine. So positive cosine and negative cosine. All right, so if I call this negative cosine, one thing that I notice is that the starting point is actually back by π/4 units to the left. So that's a phase shift. So that makes it π/4 to the left. Now, with that, I'm going to start developing my function. So the original graph is going to look like y equals some amplitude times cosine of, I'll write it, b times x minus, I guess they use a C there, and then plus D on the outside. I can't remember exactly the order of the standard variable names, but those are all the changes. That's the important part. Now, here, what's happening is I have my amplitude is 2, so A is going to be 2, but it's also flipped upside down, so it's actually going to be -2. Then cosine, and then B is my period change, which there is no period change, so that's just going to be 1. I'm going to leave that alone. But there is a shift to the left, so I'm going to write x plus pi over 4 in the parentheses. But there's also one last thing. There is a vertical shift. So right here, so this is going down. The horizontal axis has gone down 1 unit. So then it's going to be -1. And that particular function right there would produce this particular graph. Verify the following identities. Okay. So, when verifying identities, just recall you want to start with the more complex side and try and work your way to the less complex side. Usually there's more things you can cancel. So I'm going to begin with 2 tangent x over 1 plus tangent squared x. Now, for 1 plus tangent squared, I know that that's related to secant squared, and it's probably something I can work with, but a lot of times I don't remember that particular identity right offhand. But one thing I do recall is that sine squared x plus cosine squared x is equal to 1. And if I divide everything through by cosine squared x, then sine over cosine gives me tangent. Cosine over cosine gives me 1. 1 over cosine gives me secant squared. So that tells me 1 plus tangent squared is equal to secant squared. So it's important to have a means of determining things like this without just guessing at what they are, because if you guess at what an identity is, you're probably guessing correctly, and then it's going to throw off the proof of the identity. Okay, so secant squared in the denominator is actually the same thing as cosine squared in the numerator. So let's simplify and write it that way. Okay, tangent could be written as sine x over cosine x, and one of these cosines can cancel this one, so that leaves me 2 sine x cosine x, and if you'll recall, that is the definition of sine 2x. And therefore, we made it to the other side of the identity, and we have proven it. B, sine x over 1 plus cosine x plus 1 plus cosine x over sine x equals 2 cosecant x. All right, let's see what happens here. So I'm going to start with the left-hand side because it's clearly got a lot more terms in it. And since it's 2 fractions, I'm going to work on combining those into a single fraction. So to combine into a single fraction, I need a common denominator. So I'm going to write sine x over sine x times the first fraction plus 1 plus cosine x over 1 plus cosine x times the second fraction. Now, have some things that will combine, and I'm going to write this into a single fraction. So this would be sine squared x over sine x times 1 plus cosine x. Actually, let me go ahead and just combine it right now into the same fraction. So plus 1 plus cosine x squared. And now it's over the same fraction. Okay, now sine squared x I'll leave alone for a minute, but I can FOIL out 1 plus cosine x quantity squared. So that would be 1 plus 2 cosine x plus cosine squared x. And if you aren't sure of that result, you can always just work through the details of FOIL, but that's what you'll end up with. Okay, now looking ahead here, I've got a sine squared and a cosine squared. Those can be added together to 1. So I have a plus 1. But I also have a 1 here and a 1 there, which would make a 2. So my next step, I'm going to write this as 2 plus 2 cosine x over sine x times 1 plus cosine x. Now, the 2 plus 2 cosine x looks very similar to the 1 plus cosine x in the denominator. It's not exactly the same, although if I factor out a 2, now it matches exactly. So I'll cancel out the 1 plus cosine x. So 2 over sine x gives me 2 cosecant x, which is what we were looking for. So I've proven that identity. Number 5. If cosine theta equals negative 4/5, tangent theta is greater than 0, sine of beta is 5/13, and beta is between pi over 2 and pi, find the exact value for sine theta, cosine 2 beta, and sine of theta minus beta. Alright, so let's get an idea of what's happening with these angles first. So given the clues about theta, so we have, all students take calculus. So cosine of theta is negative 4/5, which means the cosine is negative. So theta is not in quadrant 1. It could be quadrant 2, it could be quadrant 3, but it's not quadrant 4 because cosine is positive there. Now if tangent has to be positive, then that rules out quadrant 3. So if tangent's positive and cosine is negative, we have to be in quadrant 3. Sorry, I think I said that wrong. We've just ruled out quadrant 2, so therefore it has to be in quadrant 3. Alright, now sine beta, here, let me just do this. So theta in quadrant 3. Alright, now sine beta, so, well, it tells us that beta is between pi over 2 and pi. So pi over 2 is here, pi is there, so beta is in quadrant 2. Okay, so that's helpful. So theta is in quadrant 3, so I'm just going to draw some angle in quadrant 3 and make a reference angle. Now the thing that I know about that is that the cosine of that angle is negative 4/5. So cosine is the adjacent over the hypotenuse, which leaves the remaining side of the triangle to be negative 3. And it's negative because I'm in quadrant 3. It makes a 3, 4, 5 triangle. For my other triangle, I'm going to be in quadrant 2. So I'm going to draw an angle in quadrant 2. So that I know the sine of that angle beta is 5 over 13. So that's the opposite side over the hypotenuse. And this is making a 5, 12, 13 triangle, but this side has to be negative 12 because I'm in quadrant 2. If you aren't sure about those sides, you can solve with the Pythagorean theorem. Okay, now sine of theta. So sine of theta, we just have to go to our chart. So sine is the opposite, which in this case is negative 3 over the hypotenuse, which is 5. So negative 3/5. That's easy enough. Cosine of 2 beta. Well, cosine of 2 beta, we do have to know an identity. So this would be cosine squared beta minus sine squared beta. So that's the double angle formula for cosine. So we need the cosine of beta. So we just come over here to beta, and it's the adjacent over the hypotenuse. So negative 12 13ths squared. And then it's minus sine squared beta, so 5 13ths squared. So this would be 144 over 169 minus 25 over 169. And when we subtract, we get 119 over 169. So that is cosine 2 beta. Sine of theta minus beta. Well, again, we need an identity to help us. So this looks like sine of theta cosine of beta minus cosine theta sine of beta. All right, sine of theta is negative 3/5. Cosine of beta is negative 12 13ths. Cosine of theta is negative 4/5. And sine of beta is going to be 5 13ths. And we just reduce and come up with our final answer. So let's see, this is going to be 3 times 12 is 36 over 65. And it's going to be plus 20 over 65. So we get 56 over 65. And that would be the value of sine theta minus beta. All right. Number 6. Use half angle, double angle, sum or difference identities to evaluate sine of 15 degrees and cosine of 75 degrees. So either ones you choose here, it doesn't make a difference in this example. But if it specifies on the test which one to use, you need to make sure you use the correct one. So I'll use a half angle for the first one. So sine of 15 we could evaluate as sine of 30 degrees divided by 2, which makes it a half angle. And if you'll recall, just writing down the identity here, this would sine of x over 2 is going to be the plus or minus square root of 1 minus cosine x over 2. And you choose the plus or minus depending on the quadrant you would be in. So in this case, this would be the positive because I'm in quadrant 1, so plus. So 1 minus cosine of 30 degrees divided by 2. And if you're unsure, grab your unit circle at this point, but cosine of 30 degrees is going to be root 3 over 2. So this is the square root of 1 minus root 3 over 2 divided by 2. And it looks like I've got a little bit of reducing I need to do. So I'll say 2 over 2 minus root 3 over 2 divided by 2, or 2 minus root 3 over 2. And instead of doing divided by 2, I'm going to invert and multiply. So times 1/2. So this is going to be 2 minus the square root of 3 over 4, which I can take the square root of the denominator. So 2 minus root 3 divided by 2. And there we have the sine of 15 degrees. Now the cosine of 75 degrees might be a little bit easier if I evaluated it as cosine of 30 degrees plus 45 degrees, because that would add up to 75. And we have the identity cosine of a plus b is cosine A, cosine B, minus sine A, sine B. So this is going to be the cosine of 30, which is root 3 over 2, times the cosine of 45, which is root 2 over 2, minus the sine of 30, which is 1/2, times sine of 45, which is root 2 over 2. So that gives me root 6 over 4 minus root 2 over 4, or the square root of 6 minus the square root of 2 over 4. And there we have it. Number 7. Evaluate the following, answer in radians. So here we're going to evaluate some arc cosine, arc sine, and so forth. So inverse trig functions. And of course we'll use the unit circle that we have prepared to do that. And the only thing we have to worry about is which quadrants we're answering with. So cosine related functions we answer in quadrants 1 or 2, and then for sine and sine related functions it's going to be in 1 or 4. So let's get started. Here's my unit circle. The arc cosine of negative 1/2, so I'm just looking to where x is negative 1/2. So there we have it. And that's at 2 pi over 3. Sine of negative 1, the arc sine of 1. So that's where y is equal to 1. So that's at pi over 2. The arc tangent of 0. So tangent is going to be 0 because it's y over x. It'll be when the y coordinate is 0. So that's at 0 itself. The arc cosine of root 3 over 2. So cosine is the x coordinate, so pi over 6. And arc sine of negative root 3 over 2. So I have to go down in quadrant 4 for sine. So negative root 3 over 2 would be 5 pi over 3. Careful, actually, not 5 pi over 3, because it's got to be in the range of negative pi over 2 to positive pi over 2. So this would actually be negative pi over 3. And how do I know it's negative pi over 3? Well, so this angle measure is rotated the same as this angle measure, which is pi over 3. So this is rotated negative pi over 3. So and you just have to answer in the range from negative pi over 2 to positive pi over 2. That's what's kind of weird about that. But negative pi over 3 is the correct answer. The arc cosecant of 2. So cosecant is related to sine. So basically we're looking for where the sine is 1/2. So sine is 1/2 here at pi over 6. And that is the same as arc cosecant of 2. Number 8. Solve the following for theta in the range of 0 to 2 pi. So 2 cosine x minus 1 equals 0. So this is a linear equation. And to solve a linear, I just need to get the variable x by itself. So 2 cosine x equals 1 to start with. Then I'm going to divide both sides by 2. So cosine x equals 1/2. Or x equals the arc cosine of 1/2. But the thing we have to be careful of is we're given a range of 0 to 2 pi. So even though the arc cosine is restricted from quadrants 1 and quadrants 2, we're going to answer quadrants 1 through 4 for this particular example. So we just want to know where cosine is 1/2. So there, oh, sorry, that's the y coordinate. I need the x coordinate to be 1/2, so right here, and again right there. So this is at pi over 3 and 5 pi over 3. And that's all we do for linear. The next one is quadratic, which is similar. We just basically have to do the same thing twice. So we have -2 sine squared theta equals 3 sine theta plus 1. I'm going to start off by adding 2 sine squared theta to both sides. I do need to factor this. Factoring is the same as it was back in, algebra, but we have the cosine, sine functions involved here, which makes it a little bit more complex. But basically what we're looking for, two things that multiply to 2 sine squared theta. So 2 sine theta and sine theta would multiply together to 2 sine squared theta. And now I need two things that multiply to 1, so 1 and 1 are my only options. I just need the middle term to add up to 3 sine theta. So I think it's going to work fine if I just say plus 1 and plus 1. Because what would happen is, 1 times sine theta is sine theta. 2 sine theta times 1 is 2 sine theta. When I add these together, I get 3 sine theta. So it works out just fine. Now, let's continue solving here. So now that we have it factored, I'm going to set each factor equal to 0. So essentially, I just get two problems that are linear at this point, and I just have to solve each one separately. So 2 sine theta equals -1, or sine theta equals -1/2. So theta is the arc sine of -1/2. To determine that, we just get out our unit circle. So we want the y values to be -1/2. So here's 1, and here's 1. So it's 7 pi over 6 and 11 pi over 6. Okay, for my other, there, that'll do. Sine theta plus 1 equals 0 would mean I'm looking for where sine theta is -1, or theta is the arc sine of -1. So I'm just looking to where the y coordinate is -1. So that happens right there, 3 pi over 2. So it looks like I have 3 separate solutions for this problem: 7 pi over 6, 11 pi over 6, and 3 pi over 2. Number 9. Change the following to trig form. Alright, so trig form of a complex number looks like, something CIS theta. So that's what we need to change here. Now, a couple of ways you could do this. You can rely on things like x equals r cosine theta, y equals r sine theta, that sort of thing. Or we could just kind of, like 12i, if I plotted that out, this is my real axis, this is my imaginary axis. So 12i is on the positive imaginary axis. Okay, so basically I'm going to write this as 12 times 0 plus I times 1. The reason I'm writing it that way is because CIS stands for, well, CIS theta stands for cosine theta plus I times sine theta. So if I have 0 plus I times 1, then I'm looking for the point where sine is 1 and cosine is 0. And if you look at your unit circle, cosine is 0, sine is 1 at 90 degrees. So this is going to be the same thing as 12 CIS 90 degrees. Now I've changed it into trig form. Same thing happens in an example like this. All right, notice that I have 2 minus 2i root 3, so it's a bit more complex. But what I'm going to do is start off by factoring out a 2. And now I kind of have some more common terms that I see with sine and cosine. I don't necessarily see a 1 and a root 3, but I do see a 1/2 and a root 3 over 2. So what I'm going to do is I'm actually going to factor out an additional factor of 2. Okay? So by doing that, I now have 4 times 1/2 minus I root 3 over 2, which if I distribute the 4, I get right back to 2 minus 2i root 3. But what that tells me is I'm looking for the angle whose cosine is 1/2 and whose sine is -3/2. So I need cosine to be 1/2, sine to be -3/2. So right here, that's at 300 degrees. So this is going to be 4 CIS 300 degrees. Absolutely works, but if you're uncomfortable with that, just recall that r is the square root of x squared plus y squared, and you could have determined it by doing, all right, so the x value is positive 2, the y value is going to be -2 root 3. We're going to disregard the I. So it would have been 2 squared plus 2 root 3 squared, which is this 4 plus, all right, 4 times 3, which is 12. 4 plus 12 is 16, so the square root of 16 is 4. So there's the radius of 4. So it matches up right there. Now, the other, we would have to do the arctangent. So theta is the arctangent of y over x. So this would be -2 root 3 over 2. So the arctangent of, in this case, -√3. So to figure out -√3, we would get out our unit circle, and we're looking for where sine would be √3 over 2, cosine would be 1/2. That's how we get it to divide to the √3. They would have to be opposite in sign. So that would give me either this option or this option right here, one of those two. In order to know which one it is, you have to know what quadrant you would be lying in. So for instance, if I drew this point out on a real and an imaginary plane, then it would be 2 on the real axis and -2 root 3. So 1, 2, 2 times √3. Let me estimate that, so I just know where to approximate a approximately put it. All right, so 2 root 3, it's like 3.46, so about 3.5. So it would be about right here. So that angle is in quadrant 4, which means this one is my correct one. So 300 degrees. Either way, you get the same result. All right, so I get the same result both ways, and I personally feel my first way was a lot easier. All right. Number 10, convert the rectangular equation to polar form. All right, to make this in polar form, we have to kind of take advantage of the things like r squared is x squared plus y squared. X equals r cosine theta, y equals r sine theta, and so forth. So these are our basic transformations. We also have tangent theta is y over x, but we generally try to avoid that one because it's a little bit messy. Okay, so I can replace x squared plus y squared with r squared. And anytime I see x, I can change it into r cosine theta, which now makes it a polar form. To make it simplified, I should get the r by itself. So for instance, if I subtract 4r cosine theta to the other side, and then divide both sides by r, I get r equals 4 cosine theta. So there it is in, r equals theta form. That would be the final answer. This next one, 2x minus 3y equals 7. I could initially change it into 2r cosine theta minus 3r sine theta equals 7. Factor out an r, and divide both sides through by the cosine theta, sine theta. So this would be r equals 7 over this whole thing, 2 cosine theta minus 3 sine theta. Number 11, convert the polar equation to rectangular form. So we're just going in the other direction, but using the same transformations. So for A, what I'll do first is just multiply both sides of this by 3 sine theta plus cosine theta. So that would give me r times 3 sine theta plus cosine theta equals 5. Then if I distribute the r, I get 3r sine theta plus r cosine theta equals 5. And r sine theta can be switched into y. R cosine theta can become x. And so we just have a basic linear equation here. All right, the next one, r equals 4 sine theta. So this is almost like something I could change into y, but I have y equals r sine theta, but sine theta itself is y over r, which means I could actually write this as r equals 4 times y over r. And actually, if I multiply both sides by r at this point, the r over here cancels, so I have r squared equals 4y, or r squared equals 4 times y is r sine theta. And now that I think about it, I didn't really need to change the y into r sine theta because I want it to be y in the end. But it's certainly easy enough to switch back. So r squared can become x squared plus y squared, and then equals 4y. If you wanted to bring those all together, that's fine. Set it equals 0. Both of those are perfectly acceptable. Number 12. Eliminate the parameter to find a corresponding rectangular equation for x equals t minus 2, y equals the square root of t plus 3. Okay, so for this, I just need to solve one of these equations for t. The easier one is going to be x. So if x is t minus 2, then t is equal to x plus 2, which I can now just put that into the other equation. So just take the x plus 2, put it in for the square root of t, y equals x plus the square root of x plus 2 plus 3. And there you have it. Number 13. Graph the following conic sections. Identify radius, vertices, foci, asymptotes, etc. Okay, so before we can really get started here, we have to identify what type of conic we're working with. So I'm just going to copy the equation down lower on. So it's 9x squared minus 36x minus y squared minus 6y equals negative 18. And what I did, I just copied the equation down, but I also moved the terms around. So I put the x's together, the y's together, constant on the other side. Okay, so I'm going to convert this to a standard form equation, and to do that I have to use completing the square. So it's going to be 9 times x squared minus 4x plus something minus y squared plus 6y plus something equals negative 18. Alright, completing the square, I take the b term, which in my first parentheses is negative 4. Divide that by 2, so that's negative 2, and then I square it. So that becomes positive 4. Now, if I'm adding 4 here, what I'm actually doing to this side of the equation is adding 36, the 4 times 9. So on this side, I need to add 36. For the second set of parentheses, 6 divided by 2 is 3. 3 squared is 9. But in effect, because there's a minus here, I'm actually subtracting 9 from this side. So I need to subtract 9 over here. So I now have 9 times x minus 2 quantity squared minus y plus 3 quantity squared. The negative 18 plus 36 would be positive 18 minus 9 would be 9. Then I'm going to divide everything through by 9. So I have x minus 2 quantity squared minus y plus 3 quantity squared over 9 equals 1. So this is a hyperbola. And I know that because there's a minus between the two terms here. But then I can identify many of the other pieces as well. So let me just recopy this up here, and then I'll start identifying the important pieces. So x minus 2 quantity squared minus y minus 3 quantity squared over 9 equals 1. Alright, so the center, that's an easy thing. It's going to be at 2, negative 3. So 2, negative 3 is right there. Now with a hyperbola we have these asymptotes, and I'm not actually going to get the equation of these asymptotes. I prefer just to kind of use the box method here to draw them. So the way that we're going to do this is it comes down to the numbers that are underneath the x and the y's. So over here, this is over 1, so I'm going to say a is equal to 1, and b is equal to, or I'm sorry, a squared is equal to 1, b squared is equal to 9, which means a equals 1, b equals 3. So on the x, which is the horizontal axis, I would go 1 unit to the left and right to find points on this box. For the y, which is the vertical unit, I would go up 3. So 1, 2, 3. And then down 1, 2, 3 is there. So I have this box right here. And that box defines the asymptotes of this graph. So there's that. All right, now this particular point here, this particular point are vertices. And they're basically, the center is 2 and -3. So I've gone just 1 unit to the left and right of 2. So 2 plus or minus 1, -3. So I'm still on the same horizontal line. So you could write 3, -3, and then 1, -3, or just list it this way. That's fine, either way. There are also foci, but the foci are located at a little bit different of a point. You have to calculate those. So you have to use a squared plus b squared equals c squared when you're dealing with a hyperbola. So this would be 1 plus 9 equals c squared. So c is the square root of 10. They're also going to be along the axis here. And square root of 10, what I'm going to do, I'm going to write the foci are located at 2 plus or minus root 10 -3. And then just to put it on the graph, I'm going to approximate what root 10 is. If this is on the non-calculator portion of your test, obviously you don't have to worry about it, but 3.2. All right, so 1, 2, 3.2, 1, 2, 3.2. So there's our foci. And then the hyperbola itself just kind of looks like a parabola going both directions, but bends toward these asymptotes. And there we have it. B, x squared plus, or minus 6x minus 8y minus 7 equals 0. All right, so again, let me copy it down here, and I'll work with it. There's only one squared variable, so I'm pretty sure it's going to be a parabola, but let's try and figure out what we can about it. Okay, so completing the square, I'm going to set up x squared minus 6x equals 8y plus 7. Completing the square, I would take the -6 divided by 2, which would be 3. Square that, and that would give me 9. So I'm going to add 9 to both sides. So this becomes x minus 3 quantity squared equals 8y plus 16. And I can factor out an 8, so that'll leave me with y plus 2. So there's my form of the parabola. So x minus 3 quantity squared equals 8 times y plus 2. All right, so this is going to be a parabola that's either opening up or down, because the y variable is the one that is linear, and that makes it so that you open up or down. In fact, it's going to open upward because the number 8 is a positive number, so it's going to open upward. So let's start identifying and drawing the graph. All right, so the center, or the vertex as it's called here, is going to be at 3, negative 2. So 3 on the x, negative 2 on the y. So there's my vertex. Now, 8 is equal to a value that is 4 times p. So what that implies is if 4p equals 8, p is equal to 2. So that tells me that my focus is 2 units away from my vertex. So there's my focus, and actually 2 units on the other side, I have my directrix. So my focus is located at 3, 0, and the directrix is y equals negative 4. Now, to draw in a decent sketch of the parabola, we need to know how wide it is. So that's where we also use the value 8 in this case, which is the length of the lattice rectum. So if you go 4 units to the left and to the right of your focus, that gives you 8 units total. And there's 2 points that exist on your parabola, so you can draw those in. Number 14, write an equation for the following. So I have an ellipse, and the equation of an ellipse looks like x minus h quantity squared divided by a squared plus y minus k quantity squared divided by b squared equals 1. Where a and b might be reversed depending on if it's, it's longer vertically than it is horizontally, But that's basically what it's going to look like. So most importantly, we need to determine the center of my ellipse. So the center of my ellipse, if I draw a couple of lines right down the middle of each one here, that shows me where the center of the ellipse is. So this center is at negative 1 on the x, positive 1 on the y. So I've already gotten pretty far in this. So x plus 1 quantity squared over something plus y minus 1 quantity squared over something equals 1. And I just need to determine what it's over. Well, the thing that it's over is the distance from the center to the end of the ellipse. So for instance, with the vertical direction, this distance right here is going to be 1 unit. And on the horizontal direction, this looks like 3 units to this point. So what that's telling me is that in the vertical direction, which is the y, underneath it needs to be the constant 1 squared, and the horizontal direction, which is the x, underneath it needs to be 3 squared. So I have x plus 1 quantity squared over 9 plus y minus 1 quantity squared equals 1. Number 15, evaluate. Write the final answer in rectangular format. Okay, so negative 1 plus I raised to the 10th power. The first thing that I want to do is change negative 1 plus I into the CIS format, the trigonometric form, because then it's just a matter of multiplying something out. So I could write this as 2 times the quantity. Actually, I don't want 2, I want the square root of 2. This would be negative 1 over the square root of 2 plus 1 over the square root of 2 times I. So why did I choose square root of 2? That seems kind of a little bit random. Same thing as earlier. I'm trying to get values that look like sine and cosine. Values of sine and cosine. So this would now become negative root 2 over 2 plus root 2 over 2i. And that tells me, sine and cosine values. You could always use, the r equals square root of -1 squared plus 1 squared. So that would be root 2. There's another way of coming up with it. But, this is how I'm choosing. Either way is fine. Now I just need to figure out, what value of cosine, or what angle measure results in a cosine that's this and a sine that is this. So unit circle. So I need cosine to be negative root 2, negative root 2 over 2, sine to be positive root 2 over 2. And there's one, and that should be the only one. Okay, so we are good. So this is going to be the same as the square root of 2 CIS 135 degrees. And then that's going to be raised to the 10th power. Now, to do this, we can now say that this is equal to the square root of 2, which I'm going to write as 2 to the 1/2 power, to the 10th, CIS 135 degrees times 10. Okay, so 1/2 times 10 is 5. So this is going to be 2 to the 5th power, CIS 1,350 degrees, which is 32 CIS, and then you have to start subtracting 360 repeatedly until you get down to, in fact, what happens here is you get 270 degrees. Just keep subtracting 360 until you get something that's in the range of 0 to 360. Now, to change this into rectangular form, this would be cosine I sine of 270. So the cosine of 270 degrees is 0, and sine is -1, so this would be 0 plus I times -1. So -32i is the solution. Number 16. Find all solutions in trigonometric form. So what we're trying to solve here is essentially x to the 4th equals -16, which means we would need to take the 4th root of -16, which is a little bit tricky because the negative underneath the square root. Now, in order to do it, what we have to do is switch this into the trigonometric form. So essentially it becomes the 4th root of 16 times, it would be -1 plus 0i, or the 4th root of 16. So -1 and 0 is here, so that's 180 degrees. So CIS 180 degrees. Now, the formula here that we work with is that this becomes the nth root of r, CIS alpha, where alpha is theta plus 360 degrees times k divided by n, and k goes from 0 up to n minus 1. This is my r, this is my n, and this is my theta. So the nth root of r is just the 4th root of 16, which is 2. Okay? So the 4th root of 16 is 2. That's that part. Now CIS alpha, we need to figure out what alpha is for different values of k. So alpha when k is equal to 0 would be, 180 degrees plus 360 degrees times 0 divided by 4. Alpha sub 1 is going to be 180 degrees plus 360 degrees times 1 divided by 4. Alpha sub 2 is 180 degrees plus 360 degrees times 2 over 4. Alpha sub 3 would be 180 plus 360 degrees times 3 divided by 4. Now, working through these, 360 times 0 is 0, so 180 divided by 4 is 45. So the first one is 45 degrees. The next one is, so if you'll notice, like 360 into 4 would be 90, and 4 into 180 would be 45 still. So this is essentially 45 plus 90, which is 135 degrees. So 4 goes into 360, that gives me 90, gives me 45 here. 90 times 2 is 180. 180 plus 45 is 225 degrees. So 4 goes into 360, that's 90. And this is 45. 90 times 3 is 270. 270 plus 45 is 315 degrees. So those are the different values there. So my solutions are 2 CIS 45 degrees, 2 CIS 135 degrees, 2 CIS 225 degrees, 2 CIS 315 degrees. Those are the 4 roots of that formula. All right, now the remaining problems you'll be able to use a calculator. This will be on the calculator portion of the test, and you're kind of expected to use one so you can approximate your answers in the end. But let's get started with some examples. So from a point on level ground, 92 feet from the base of a tower, the angle of elevation to the top of the tower is 35 degrees, 20 minutes. Find the height of the tower. You may use a calculator to approximate the answer to the first decimal. So we have a tower here, and you're 92 feet away from the tower. There's an angle of elevation to the top of the tower, which measures 35 degrees, 20 minutes. And we're trying to figure out what that value is right there, which is the height of the tower. So if you'll notice, I could relate these through tangent and say that the tangent of 35 degrees, 20 minutes is x over 92, or x is equal to 92 tangent 35 degrees, 20 minutes. And if I put that into the calculator, I can get an approximation. Let me just bring it over this way. All right, so 92 tangent 35, go into the angle menu to get the degree, and then it also will do the minute for you as well. So you don't need to worry about converting. It'll do that for you. So 65.2, and I believe this was in feet. So about 65.2 feet. Number 18. To determine the distance between 2 points A and B, a surveyor chooses a point C that is 20 yards from A and 17 yards from B. If angle BCA measures 83 degrees, find the distance between A and B. You may use a calculator to approximate the solution, rounded to 1 decimal place. All right, so we have some points A and B. We're trying to figure out the distance between them. So I'm going to call that x. But then we have a third point C, And we know the distance from C to A, that's 20 yards. And then the distance from C to B is 17 yards. And the angle BCA, so that's this one, is 83 degrees. Now, in order to figure out what x is, I need to use the law of cosines. So the law of cosines would tell me that x squared is equal to 20 squared plus 17 squared. It's basically like the Pythagorean theorem, but you just can't assume you're using a right triangle. And if you don't have a right triangle, you have to do this part. You have to say minus 2 times 20 times 17 times the cosine of the angle between them. Okay, so then we'll get out the calculator and come up with an approximation. So 20 squared plus 17 squared minus 2 times 20 times 17 times the cosine of 83 degrees. And let me just real quick check to make sure I'm in degree mode. You can see how degree is highlighted, so that's good. And looks like I get 606.1, but that's equal to x squared. So if I take the square root of that answer, I get 24.6. So x is approximately 24.6, and we're measuring in yards here. Number 19. Two forces of 695 pounds and 325 pounds act at a point making an angle of 53 degrees. Find the magnitude of the resultant force and the angle between the resultant force and the 695 pound force. You may approximate the solution with a calculator, rounding to the first decimal. All right, so we have two forces acting on a point. One force is 695 pounds. The other force is 325 pounds. The angle between the forces is 53 degrees. Oops, not 530. So 53 degrees. And we want to figure out what the resultant force is. So, the resultant force would be going this direction. Okay, so let's start with the magnitude of the resultant force. So the magnitude of the resultant force, if I think of vectors in terms of, the tail to tip method. There. So the magnitude of the resultant force is going to be that diagonal right there. But I can't quite figure that out yet. I have to kind of maneuver things. So 325 would also be this length here. And the known angle is 53, which means this one right here is 180 minus 53, which would be 127 degrees. Moving things around that way, it allows me to say, all right, if this length is x, then I can figure out x by doing, let me switch back to blue. X squared is equal to 695 squared plus 325 squared, all right, which would only work if you had a right triangle, but the law of cosines extends the Pythagorean theorem. So minus 2 times 695 times 325 times the cosine of the angle between, which is 127. So that I need to put into the calculator, and I'll get an approximation to what x is. Okay, so here's my calculator. So 695 squared plus 325 squared minus 2 times 695 times 325 times the cosine of 127 gives me a large number, but remember it's the square of my answer, so I need to take the square root of that, and that results in 927.6. And this was in pounds. Okay, now the angle between the resultant force and the 695 pound force. Let's get that next. Now this can be a little bit tricky because the first angle that's actually easiest to solve for would be this one. I'll call this theta. Alright, but that's not the angle between the 695 and the resultant force. So let me draw this a little bit better. The resultant force is going to be going this way. Okay, so the angle between the 695 and the resultant force is actually this angle right here. So it would be 180 degrees minus what we came up with for theta. So I'm going to solve for theta first and then come up with that angle measure second. Okay, so to solve for that, it looks like my best bet is to use the law of sines. So what I can do is set up sine of theta divided by 325 is equal to the sine of 127, oops, 127 over 927.6. Now, you generally want to avoid using values that you've just calculated, but in this case, there's really no getting around it. You know, because otherwise you'd need to know the other angle. In order to calculate the other angle in this triangle, you would need, you know, the 927.6 also. So there's no getting around it, and that's okay. So sine of theta is 325 over 927.6 times the sine of 127 degrees. So let me get out the calculator to approximate that. So 325 over 927.6 times the sine, times the sine of 127. That gives me that. But that's the sine of theta, so I need to do the arc sine of that answer to get what theta is. So theta is about 16.2 degrees. And I should be careful and put, oops, erased everything. Approximately 16.2 degrees. Now, if this is 16.2 degrees, then 180 minus that is actually the angle we're looking for. So this would be 163.8 degrees. And there's our final answer. Number 20. A ship leaves port at noon and heads due west at 20 knots. At 2 p.m., to avoid a storm, it changes course to north 54 degrees west. Find the ship's bearing and distance from the port of departure at 3 p.m. You may use the calculator to approximate the final answer, round to 1 decimal. Alright, so I'll say this is port. Oops. Back to blue pen. Here's a north line. And the ship travels due west for 2 hours. So goes due west for 2 hours and traveling 20 knots, so this would be 40 knots away. Or 40 units, whatever, nautical miles, I suppose it would be. So then it turns, so I need another north line, and it goes north 54 degrees west for 1 hour. So this right here is 54 degrees off of north. It travels 1 hour, so this is a distance of 20 nautical miles. So what we want to know is how far away is it from port. So what's that distance right there? And what's its new bearing? Okay, so let's figure out the distance first. Now, we could almost use law of cosines if we knew what this total angle is. This part right here is 90 degrees. 90 plus 54 is going to be 144 degrees. So this total angle right here, from here to here, is 144 degrees, which is great because I can use that to solve for d. So to solve for d, I would say d squared is equal to 20 squared, oops, force of habit, 20 degrees, 20 squared plus 40 squared minus 2 times 20 times 40 times the cosine of the angle between them. So get out the calculator, let it do its thing. So 20 squared plus 40 squared minus 2 times 20 times 40 times the cosine of the angle between, and we take the square root of that. So 57.4. So that distance is approximately 57.4 nautical miles. Leave it to me not to be able to spell that. Okay, so d is equal to 57.4, and that's going to let me solve for some angles here. Now, the angle that I think I could solve for first would be this one. And I'm going to call this theta so that I have a name for it to solve. And I think I can solve for it using the law of sines. So the way that would look is this. So the sine of theta divided by the side that's opposite it, which is 20, is equal to the sine of 144 divided by the side opposite it, which is the 57.4 that I just solved for. So sine theta is 20 over 57.4 times sine of 144. We'll get the calculator out to help us here. So 20 divided by 57.4 times the sine of 144. And I take the arc sine of that. So that's 11.8 degrees. So theta is approximately 11.8 degrees. So this is 11.8 degrees. Now the problem with that is that that's not technically a bearing. All right, that's a direction from west. But the bearings are directions from north. So I actually need to know what this angle measure is right here. But that's pretty easy. That's just going to be 90 minus the 11.8. So if I take 90 minus 11.8, I've got 78.2. So what that means is that the ship's new bearing is north 78.2 degrees west. Number 21. Given vectors u equals 3, negative 4, and v equals negative 2, 1, evaluate each of the following. You may use a calculator to approximate solutions to one decimal place. Part A, evaluate the dot product u dot v. Alright, so a dot product is pretty straightforward. you're just going to multiply the corresponding elements of the vectors. So 3 times negative 2 plus negative 4 times 1. This would be negative 6 minus 4, negative 10. Part B, find the magnitude of vector u. So the magnitude of vector u is the square root of the sum of the squares of its components. So 3 squared plus negative 4 squared. So the square root of 9 plus 16, or the square root of 25, which is 5. Find the magnitude of vector v. That's going to be the square root of negative 2 squared plus 1 squared. So that's the square root of 4 plus 1, or the square root of 5. And determine the angle between the vectors u and v. So the cosine of the angle between two vectors is equal to the dot product of the vectors divided by the product of the magnitudes of the vectors. That's kind of why we've come up with all the different pieces here already. This is a formula that you'll need to know. So in our situation, the cosine of theta is going to be the dot product u dot v, which we had as negative 10, over the magnitude of u, which was 5, times the magnitude of v, which is the square root of 5. Now 5 goes into 10 2 times, so I have negative 2 over root 5. So what that means is that theta, I should write it in this way, so theta is going to be the arc cosine of negative 2 over root 5, which is going to be approximated by the calculator. So arc cosine of negative 2 over root 5, about 153.4 degrees. Yeah. Looks like a 6. 153.4 degrees. And that's the angle between those vectors.